Welcome to Model 15, Vulnerability Analysis. In this model, we start with a brief introduction about vulnerability concept, the type of threats, vulnerability elements. Then we propose a qualitative assessment concerning reliability and a quantitative assessment to measure the vulnerability of a system. Then we go through a case study exercise. Then in the end, we get some conclusion about the coins and drawbacks. So why you understand the vulnerability? Vulnerability can be defined as a lack of protection of or fragile that one system has and can be exploited by external force. So that's a qualitative concept. When we have also a quantitative concept. The system vulnerability can be described mathematically by the frequency of the system is susceptible to all threats and this threat is successful. So why the question is why we are talking about vulnerability. So we need to understand that so far we discussion about process risk that's posed in the process, and such risks are under company control. When you're talking about vulnerability, we're talking about threats that's not under company control. But such threats can also cause damage to physical assets and trigger major accident. That's why it's important also to introduce the concept of vulnerability in our training about risk management. So when you're talking about reliability, and as I mentioned, reliability, vulnerability, and threats can trigger major accidents, we need to consider different elements. So the these major accidents can also not only be triggered by failure in internal physical asset equipment failures or failure in one of the layer of protection, but also caused by natural disasters or sabotage such as hijacking, terrorist attack, or other factors. The other points that we need to consider is the application of vulnerability. We need to plan to make an analysis, identifying the attacks, training people, constantly monitoring, test the systems, the control measure and the recovery measures that we have in case of threats, susceptibility. We discussing all this concept later on, and we need to consider real-time response for that such threats that attack and put our system vulnerable. And of course, understand the impact of such threat attack, the vulnerability of our plants, that the effects can cause damage for the population. And we need to understand the resource that are involved in such threats, effects, attacks, and we need to understand which are the response agents that we need to take into account in case of threats, attacks, and that's our physical assets, our plants are vulnerable for such physical attacks. So these threats are real. So let's take a look on some historical that's happened in an industry to see what's happened. So in 1999 in Washington D.C., a database developer worked on a SCADA system while the system was being used to operate the pipeline. So there was a maintenance SCADA system, but the system is still operated. So the effect, so some hacker came in, there was a pipeline and work on it, sabotage that, and then as the effect was a pipeline rupture, and the effect was 237,000 gallons of gasoline leakage. So the consequence was 8 serious injuries, 2 deaths, environmental impact, and property damage around 45 million. So in April 2000, we have also another treatment plants in Australia. So that was here another hacker attack by laptop. So laptop has been used at the time of the attack, and his hard drive contains software for assessing and controlling the sewage plant management system. And after 6 attempts to control the system, so you see here the characteristics that's you need to monitor the threats along the time and even and always to measure to be sure that the countermeasures are efficient. So the effect was meters of liters of raw sewage spilled out in local parks, rivers, and even grounds in a hotel close to the area. So there was a catastrophic environment effect. So in August 2003, in US as well, computer virus was blamed for bringing down train signaling systems. And then in this type of attack, that was able to shut down all the trains, stop the trains, but that's going to cause a train collision. That's also a event uh, that cause deaths in the population. That was causing a virus effect in a computer system. So another in 2004, one virus brought down IT system. So that was a coast-wide IT system available. So that means this emergency team was not available for a period of time. If there was some emergency response, they were not able to support. So you can see that the threats are real, different source of threats. We also have natural disasters that affect such physical assets such plants, refineries plants, petrochemical plants, and then of course it can trigger major accidents. So let's take a look on different types of threats. So the first one is the sabotage threat. So that is a model that's created for the Mr. Chatelain in 2007 that described basically that the threats can follow different routes and in different zones of attack, and then such different routes change along the time, and then you need to consider the different possibility of entrance or routes of attack in case of a cybersecurity, for example, different routes of entrance or even sabotage, different points of sabotage that the threats can try to sabotage, shut down the system, or even cause a major accident. So, of course, natural disaster, that's a common natural disaster that are flooded, on a flooded refinery. And then, of course, this can also trigger an accident if you not have the procedure to shut down the plant in a proper time. Another type of as a vulnerability is the cyber attack. So this one, as I mentioned before, there was some case that plant was sabotage, but was attacked by cyber attacks, hackers, and then of course you need to pay attention in different types of uh, of interest in the system. So you need to consider that people have no access to the main IT system in the company. You need to control the access. You need to, of course, pay attention in networks that are in internally in the company, mostly the internal network and also connections with external networks. In some case, when you consider plants that can, in case of control for a hacker, they can trigger a major accident as we saw. So we need to isolate the servers and control the access to the servers, the IT, as well as the configuration of the IT system need to be isolated for external access. And that is how we are considering that when we have some, let's say, weakness of such configuration or access, so the cyber attacks can come in. So in general, there are different types of threats: hackers, insiders, phishers, spammers, and spywares and malwares, authors. So in this case, if some of them succeed, we have a cyber attack. So Fisher are emails that you can receive, for example, and get some information. You open a file or give this information, then the virus install in your computer. This virus can remain in your computer for a lot of days after be set up to attack and get information. Then, of course, the effect was to cause some sabotage for the internal control system, and trigger a catastrophic event, or get confidential data, or even shut down your plant. So of course, you need to implement control barriers against each one of them. For example, against hackers, you need to have password procedures change from time to time, to renew the password interval, and have effective firewalls. For insiders, you need to have physical security, limit the access for a specific area, and have IT security policy and procedures established for all employees. Phishers, you need to also to have email security softwares and IT security policy and procedures to not open emails, or depends on the email or the site, not be open in workplace. Is spammers, IT security policy, email security software, and anti-spam. So that's also information and request that you open, and then you open a file that comes out of virus, and spywares, malwares. Here we need to have firewalls, antivirus, intrusion detection, intrusion protection. So, and that's all our countermeasures against these threats, different threats of cyber attacks. So if the cyber attack succeeds, so you need to have some recovery measures. So now, if you have your ICS system are in attack, you need to avoid security setting modifications. And so that's in some cases they try to do, and shut down automated to manual control operation, and then this until you eliminate the threat. So in case of confidential data, you to avoid that, you need to create some cryptography and data destruction to avoid that they collect the threat gets the information. And here ICS shut down, loss of production. Again, you need to avoid security set modification, shut down the automation to manual control. So those are some recovery measures. So here you can see that some of recovery measures are shut down the automation to manual controls that cause some issues that you need to control all the whole plan manually. But even though it's better than let these threats get their objective and control the plan, it generates some cyber attack. Okay, so in the end, you need to consider all the vulnerabilities and natural disaster, terrorism attack, and cyber attack, and have a system that are able to cope with all of them. And that's we need to have a specific emergency plan, not only concerning your internal major accident, but also natural disaster, emergency against the plan for against terrorists, and also IT security. And then, of course, you have your control measures and your recovery measures to adapt that. So let's take a look now which are the vulnerability elements. So basically, we can say that we have in the first as a threat, and is that or some people say it's hazard, but I would like to call threat because it's something that is not under your control. And then you have the exposure of your system. This threat are susceptible. So susceptibility, the capability that the threat has to go inside your system. Then, of course, in order to avoid that these threats be successful, so you need to have some coping capacity. So your countermeasure, recovery measure will act to neutralize these threats. And then in the end, this you have the criticality. And how is in the end your vulnerability? So your vulnerability is combination of susceptibility, the probability of susceptibility that depends on the countermeasure to avoid that the threat comes inside your system, the copy capacity that since the threats are inside your system, you are able to neutralize them and avoid the consequence. So the vulnerability methodology has 9 steps in general. So the first one is to identify the threats. The second one is to define the threats detection and monitoring routine. So it's very important that here you try to define how to detect such threats and monitoring routine. So if you have a natural disaster as a threat, you need to monitoring and having contact information with the government organization that's monitoring the weather, that make it such a study and collect this information in order to predict, for example, ahead of storms periods, in order to be prepared, and even in case you need to shut down some plants, you are prepared to do so. Another kind of threats, of course, are sabotage. You need to have a very good security policy and always pay attention on all in interest in your organization, and control all the areas that such threats can come out and cause some damage for a system, or even shut down, or including a virus. And cyber attacks, that's the one that is the hardest one to control. Actually, every company have millions of attack per hour, but they have an effective system that are able to detect and monitoring that and avoid that such threats to be susceptible to their system. But that's not means they will not go inside the system. They are neutralized in most of cases. That's why we need all these countermeasure, recovery measure against cyber. So after that, you need to identify the susceptibilities. How is the route that the threats go inside your system? Then you need to define susceptibility detection. So you need to define the routes and how to control such routes. So in case of a company, if you have some sabotage, someone from outside need to come inside, there are some rules that are impossible for some external people to access, but there are some rules there that is easier. So you need to control such rules, routes, as well as in case of cyber attack, for example, the emails that are people using or open files. So that's hard. Sometimes you get an email and you believe that it's a safe source, and you open, so your computer is affected with a virus that can cause damage for a whole company, as well as pen drivers that you install in your computer. So the IT policy need to care of that, of this cyber attack threats, and have a specific procedure. And in many cases, the big problem is that the IT do not clarify why the such procedures, why you need to always to before install some when you install some drive in your in the company computer, you need to go through the antivirus, for example. So people has no awareness about vulnerability and which kind of threats are posing against their organization. And then of course there is need for a high communication level in order to provide enough information for people to be aware about that. Then they will be committed and work together with the company to avoid that such threats susceptibility. So here we need to define, after you understand the threats and how they and the susceptibility. So you need to define which are the best control measure, define the control measure, the copy capacity, and the recovery measure, and then of course you can measure the vulnerability of your system from time to times and constantly assess that. And of course, another point is that you need to assess is the possibility to, even when the threat cause some damage, how is the possibility that you have to recover from this threat. So this possibility to recover this from a threat attack is so-called resilience. But what we try as a concept is as soon as possible to neutralize the threat, and if it's possible, avoid that threat to be susceptible in your system. So we need to be careful. Vulnerability change along the time. So depends on the time, you have different level of vulnerability as well as different threats. Threats are not under our control. That's why that requires another management, another understanding about how manage vulnerability, and the vulnerability that the organization is exposure, and understand that in many cases we need to work together with the government organization, with the police and other organs to be able to detect and monitor the threats. Another point is that constant communication about vulnerability in order to increase the awareness about the threats. So, and then a problem and issue that we have mostly are about the hackers and the IT policies, they do not clarify in many cases why they have a lot of procedures to use computers to access work sites, so websites, and to use pen drivers and so on, install softwares in their computers, but that's need a communication about cyber attack. And in my experience when I work in company, that was not the case. That's just some procedure I need to follow up. So that's not good because people are not aware about that. So necessary to establish vulnerability program, and such vulnerability needs to be in place since the design phase. So in design phase is similar that we do to identify the hazards and make risk analysis and propose mitigations. We need to do similar with threats. And threats are external elements that can cause damage in your system. So you have no control, but you can identify that. So as soon as you are able to identify and define some how you identify, control them, and monitoring them, at least monitoring them, will have your system will be less vulnerable to such threats attacks. And then, of course, you need to establish mitigation actions in case of IT that we have higher hacker attacks. You can have a lot of IT system configuration that minimize such attacks. And of course, control measure, recovery measure managements all along the time. So usually as a risk analysis, you need to measure such recovery measure and control measure in order to be sure that in case of threat susceptibility, you will be able to mitigate its effects as in a short period of time. So constantly vulnerability procedure reviews. Of course, vulnerability is a new concept. We do not have this concept spread out in our industry. People have different understanding, and because of that, you need to constantly review such procedure and try to implement much better uh, methods to avoid that such threats become impact your system. Vulnerability program involved in all organizations level. So, and that's why it's important here to have the top level managers, leaders involved in vulnerability programs in order to enable the mitigation in the of such threats. And of course, that will also request investment on it in training, in countermeasure and recovery measure, in better configuration, IT configuration, and better security procedures or more security resource to control the facility. So that's all in the end involve the high level organization. So qualitative vulnerability, we define it, is considered can be considered by an index, and this index will be the number of, for example, fatality that is caused for a threat. So whenever the vulnerability is higher than one, is expected higher than one or more deaths is a non-acceptable level. So we have qualitative classes, and then we can quantify the vulnerability for and from zero higher than 0.1 to 1, and then of course we get the expected damage. Of course we can put in here the expected damage in terms of cost for the facility as well. We also have a quantitative concept of vulnerability, and the quantitative concept that vulnerability is the susceptibility multiplier for the copy capacity multiplier for expected number of deaths. So here we have susceptibility of the system that we go. So if this the threat is susceptible susceptible to the system, we have the probability of copy capacity. If it fails, we multiply for in the end for expected number of deaths caused by this effect of this type of traps. And in the end, depends on how many source of threat. For each source of threat, we will have a specific vulnerability. In the end, we can add all the source of threats, and we have our final vulnerability. And then, of course, we can come back here and see if it's acceptable or not, the level of vulnerability. So lower as much as possible, better will be the level of vulnerability. And of course, how we calculate the susceptibility is the expected number of threats at a specific time multiplied by the threats control measure failure probability. So you have a number, expected number of threats, and if the multiply for the probability of this countermeasure failed for each threat. So if it's zero, the susceptibility is zero, the vulnerability is very low. So if you have a very effective countermeasure here in a specific period of time, so that will have zero probability of failure, very low. So no matter how much expect number of threats you have, so the susceptibility will be annihilated. Then of course your vulnerability will be close to zero and be very 0, 1. If your control measure is not enough, so of course here your susceptibility will be will have a higher number. Then of course your copy capacity need to be lower enough to mitigate in that. So if your copy capacity, if you have high susceptibility but you have a very high very low probability to copy capacity fail, in the end you mitigate also your vulnerability no matter how is the number of deaths that's caused. So your vulnerability is very low caused by your copy capacity that's close to zero. So this vulnerability also will be close to zero. The ideal situation is that you try as much as possible to mitigate your susceptibility by have a control measure that mitigates the number of threats to be successful to the system. But if it's not possible, you need to combine in some cases as well the copy capacity. So that's the case of cyber attacks. So millions of tentatives of go into in IT organization system. Some of them are successful, but you have also countermeasures that are able to eliminate such threats, and then the vulnerability in the end is low. So now that we understand, let's take a look on vulnerability case study. That is I have I have rain that we had in Rio de Janeiro city. Why I consider natural disaster a vulnerability case is because we can have an impact in a refinery plant. So we talk, as this training is for oil and gas industry, you need to consider the impact in oil and gas caused by vulnerability. We saw in the very beginning there were some cases that in pipelines that was a rupture of pipeline and also sabotage that cause environmental impact. And then, of course, a natural disaster can cause a rupture of pipeline, can cause leakage in pipeline or an oil spill. So you can see here in this region. That's why we are considering the hazards, this natural disaster as uh, uh, a case study. So if you're looking here, the historical of heavy storm in a regional city, we can see that along the time we have a lot of the numbers. We have this table that represents the, the heaviest rain. So you can see here, if you look at the number of deaths, so some of them are very higher. The worst one was in 2011, and we had one in 2016 with 250 deaths. So we can see how many people are injuries in this column here, and families and how destroyed was also the worst case scenario. We do not have all data about economic loss, but those are the most important things. And then what we're plotting here is the interval of between such heavy natural that we consider a natural disaster that are heavy storms occur in the city. So we are here arrange the data in a format that we can use the Crow-Ansel model. So this Crow-Ansel model is applied to predict the accumulated number of events or failures, to predict the trends of interval between events or failures, to predict the trends of intensity of events. Then we need some parameters, and we need to plot such curve as in this format. So based on it, we apply simply this equation that considers beta parameter the initial intensity of failure and the time that you expected to define actually here what we expecting to define the next failure. So we apply as an expect number of failure the 10th failure when is going to happen. So we calculate the initial height of having a storm and the beta coefficient. So how we calculate these two parameters? We know that we already had 9, so we want to know when, in which time that's happened, the next one. So here is a calculation that we got the values from the table before, so we can calculate the beta that we use in here and the intensity failure, initial intensity or height of heavy rain. So we calculate that we applying this equation. Then with our prediction is 53 years that will be the next rain. Why this prediction is important? Because we know now the range of time that we have to implement all countermeasure, recovery measure in order to avoid such threats that we cannot avoid in this case, that's natural disaster, cause effects in people's lives and society. So here there is a graph that you can use also a software to plot the cumulative number of failures, and then of course in the software you get all the information automatically. Then with such information, you know that in 3 years you have a heavy storm, so you need to work in the weather prediction, and that's starting to have we apply our methodology, vulnerability analysis methodology. So we identify the threats that's a heavy storm. So now we have the threats, we monitor and control that. So our control measure is weather prediction and population alert, population dislocation to safe area. So those are the countermeasures that we have. So if that fails, we will have, in any case, we will have the flood in Rio de Janeiro area. But if you are able to isolate the population, that's not affect them. But if it's not, we need to have the firefighters response because not an industrial area. Then, of course, if it's not effective enough, that we will have some depths, not for only for a flooded area, but also for landslides. And here, of course, we can include more one disaster here that will be in a refinery. Some heavy rain, we have flooded area, you have a pipeline rupture, and then you have oil leakage in a river, for example. Okay, so now we are starting to include all type of potential cause. So here are depicted all the control measures, what's happened in the cause of loss of control measure. That's the susceptibility, probability of rain affect Rio de Janeiro City. We have a recovery measure as an emergency response, and the consequence we have that. So those are the elements. So concerning next 5 years, expect 1.7 heavy rain in 1.7. Expect number of heavy rain is 1.7. So the following both time consider the following information. So we have one potential have a rain. The probability to have the first weather control monitoring alert is 100%. The population relocation is 100%. That will fail. That's probability to fail. And then we multiply for 1 here. So we will have the effect of heavy storm. So here is considered that we do not have, in this case, a good weather monitoring and alert system, and population relocation that should not happen. Most of population affected are living in favelas. Because of this, the government, local government, do not have a policy to relocate these people, so they will not be relocated. So in this case, we need to have a loss of control, so there will be a susceptibility, probability of having rain affect the Rio de Janeiro city will be 100%. So the recovery measure is only about the emergency response, the firefighters. If we consider that they are able to save all the lives, there is not. So we consider 100% fail. So we have at least one death. So seems that this scenario is negative, is pessimist, but that's unfortunately is the reality. We can change the scenario, working control measure, of course, and copy capacity, but that's not what's happened. So an exercise here. So now I calculate my vulnerability. So I have one threat here, expect number of heavy storms. So I multiply for this 100% of all effects. In the end, I have one death in the next 3 years. So that's my vulnerability index. So higher and equal to 1 is unacceptable. So this unacceptable means I need to do something to, I must do something to reduce this vulnerability. So that is how we calculate. We, in case that we have only one threat as natural disaster, we consider that. If we have more others threats, we do the same calculation for other threats. In the end, we will add all this vulnerability, and then we will have some numbers and some levels in here. So, vulnerability analysis conclusion. The vulnerability analysis advances to prepare organization to threat response, to enable threat identification and monitoring. In some cases are harder, such as hacker attack, but even though there are a lot of solutions that you can implement to mitigate such attacks, enable the control and recovery measure definition for each type of threats. So that's very important. Identify all type of threats and prepare a vulnerability plan based on vulnerability program. So, and that's the advance to start with a vulnerability analysis. That's something that's not clear. Again, it's not something that's all organizations understand that they need to implement. The vulnerability attacks drawbacks is difficult threat monitoring. So you need to justify in many cases investment, but you, if someone questioning you about the effectiveness of monitoring, in many cases you cannot answer because you have no this information. So different understand about vulnerability as well. Many people understand vulnerability as a risk and parts of risk management, but actually it's not. Again, vulnerability is related to threats, and threat is something that you not control. It's an external events or someone that can cause damage in our facility that you not control. Lack of vulnerability programs. So definitely in many designs there is no vulnerability analysis into consideration. Now it's time to have some concerning about ITs and cyber attack, but we need to go further and consider also natural disaster and other events such as sabotage and lack of responsibility perception. So if we have no program, of course, people will not feel responsible for vulnerability analysis. So this vulnerability analysis methodology are defined in my book, Safety Science, in chapter 4. You can get information about that. Thanks for attending this model. And if you have some questions, just send to me. So let's move to the next model.